So one quick example before we get to well, actually, let me give like a kind of quick, easy way to do the conversion process. So how would we determine that two equations are the same or equivalent to each other? Well, if I write log base b of x is equal to y, there's a quick and easy way to remember how to go to the exponential form and vice versa. You always start with the base. So here's the base b. Starting with the base, you can create this little heart shape. Okay, this is equivalent to the equation b to the other side of the equation, y, is equal to what's inside. So we get this little heart shape. So starting with the base, starting with this base here, b to the y is equal to x. And you can convert back to the other side the same way. So starting with the base here, b log base b of x is equal to y. So to go from one form to the other, just remember that little heart shape. All right, so we start with the base, always start with the base. If you're starting with a logarithm, okay, to go to exponentiation, it's b to the power y is equal to what's inside. B to the y is equal to x. Looking at the right-hand side, we start with the base. We say log base b of x is equal to y. Now, before we get to the actual examples on the 4.2 handout, there's a couple of important logarithms, just like with exponentials. I mentioned like e to the x is an important exponential function. There's a couple of important logarithms to know. So just note there are two functions. So the first one is just log of something, log of x, this function here. If you do not see a base, kind of like when you're dealing with square roots, you don't see like a number where the root is, like you can't tell what kind of root that is. So starting, if you have a logarithm that does not have a base, it's assumed to be log base 10. This is log base 10 of x, whether or not it's written. So a logarithm that does not have a base is log base 10. It's the inverse. This is the inverse of 10 to the x. Remember, log base b of x is the inverse of b to the x. So if you just have log of x, it's the inverse of 10 to the x. That's an important function because we often think in powers of 10, right? 1,000 is 10 to the third power. 1,000,000 is 10 to the sixth power. That's just our daily life base there. Another important logarithmic function is the natural logarithm. So this is the natural logarithm. Oh, let me erase that question mark in the arrow. So the natural logarithm, we denote that as ln, not in, ln. Let me make that a script L, just for emphasis, ln of x. If you see ln of x, this is log base e of x. Remember e from exponentiation? Well, it's back again for the definition of this important logarithm. Now, just a word of warning, these aren't universal definitions. These are common definitions for this level of material, but some software, some companies default into saying log of x is the same thing as ln of x. Some sources will tell you that they are the same. So just a word of warning there. Whenever I write log, it means, so if I write log of something, it means log base 10. If I write ln of something, it's log base e. in future mathematical contexts, you may see that they change these definitions just a little bit. So just be aware of that. What I'm teaching you here is common. It's the common definition of log and ln. All right, so this is the inverse of e to the x. If you do intend to go into something like computer science, they have this other function. This is log base 2. So if you see, so this is log of x, natural logarithm 3. If you see lg of x, this is a common computer science application. It's a common computer science definition. This is log base 2 of x. This is used in a lot of, I mean, the reason why 2 is important as a base is that, well, our computers work on zeros and ones, right? So there's one second. So powers of 2 are really important, right? So for example, if you haven't seen the joke, there are 10 people who understand the statement. Those who understand binary, meaning digits of 0 and 1, and those who don't. Then you'll understand why log base 2 is important here. Okay, so I would take a look at that. I would look that up on Google if you're interested in computer science, but other than that, we're not really going to be using that. So the first two here are really what we're going to be using as definitions. We have to know that log without a base is log base 10, and log that has an ln is log base e. Okay, so now that we have that covered, we know that logs are the inverses of exponential functions. They undo each other, right? So if you take an x value, you plug it into log base b of x, you get some number back, and then you plug that into, so this is, I'll call this f. If I were to plug that into g, right, the b to the x function, the b to the x function undoes the logarithmic function, and you get back to where you started, right? That was the definition of inverse. Similarly, you can plug x into, we're doing the reverse order here. If you raise the number b to the x power, and then you plug that into the log base b function, so this is g, this is f. Again, they cancel each other out. Just like if f were multiply by 2 and g were divide by 2, they undo each other. All right, so that's how we define logarithms. So how do we evaluate? Evaluating. How do we evaluate? Well, again, we want to think in terms of exponentiation. So what it means, so to evaluate, log base b of something, we need to think what do we raise to the power of b? Oh, sorry, as the power of b. Such that e equals x. Okay, so that's how we evaluate logarithms. What does log base b of x mean? Well, that's the power that we raise b to. what power do we raise the base to that gives us x, right? So we use the equivalent, again, the equivalent forms. So I want to know, again, what log base b of x is. So I'm just going to call that y, right? So I'm interested in finding the value of y here. And how do I find that? Well, you have to think kind of backwards. So remember, this is equivalent to b to the y is equal to x, our little heart shape here. I want to know what power of b is equal to what's inside the function. That is what the logarithm is. Okay, so we're gonna work on the handout examples now. The first 8 of them there. So let's look at the handout examples. Okay, rewriting, first of all, in its equivalent exponential form. So rewriting in exponential form. So look at the first one. And the whole point of rewriting in exponential form is just to get used to the whole process of logarithms here. So if I have log base 2 of x is equal to 2, what does this mean? Log base 2 of x is equal to 2. Well, to rewrite that, I'm going to start with the base. Okay, I'm going to say 2 to the power 2 is equal to x. And from there, you can actually determine that x has to be 4, right? So if we were solving this equation, which we will do in the future, the solution would be 4. We're not worried about that now. We're just rewriting in terms of exponential functions. So to understand what log base 2 of x actually means, what does it mean for that to be equal to 2? It means that if I raise the base 2 to the other side, which is 2, it should be equal to what's inside. Let's look at the next one. Log of x is equal to 2. This is basically the same idea, but now you don't see a base here, right? There's no base. Remember what we talked about before? So if there's no base, we assume that the base is 10, if you don't see a base. So we assume that there's a base of 10 down there. And we say, well, this is the same thing as saying that 10 to the second power is equal to what's inside. Again, from where you can conclude that x is actually 100, but we're not concerned with that right now. Number 3, we have ln of e is equal to 1. So how do we write this in its equivalent exponential form? Well, remember ln is a special logarithm. That's the same thing as saying log base e of e is equal to 1. Okay, so once we know the base, we can rewrite it in terms of its exponential form. We start with the base, e to the power 1 is equal to e, which is true, right? If I raise some number to the first power, I'm just left with that number. Remember, e is about 2.7, so it's a number, and we can use that as a base. It's positive and not equal to 1, no problem. So we're just translating like 2 different languages here. Some people might speak the logarithmic language, some people might speak the exponential language. Okay, we're just translating from one to the other. Let's just do this last one here. Number 4 here says log base 4 of 1/16. That's equal to -2. And this is another true statement. Like the first 2 here, the first 2 examples, we had a variable expression. So is it true or not? Well, it's only true when x is equal to a certain number. These next two are just true statements. So here, I'm going to start with the base again. 4 to the power -2 is equal to what's inside. So that is the exponentiation dialect of this statement here. So knowing how to go from logarithmic form to exponential form, the whole point is that it helps our understanding on exactly what a logarithm is, right? So in the next video, we're going to talk about evaluating. So for example, let's go back to, where was it? It's here somewhere, unless OneNote deleted that for me. Probably did. Where are you? Oh, here. What is log base 2 of 8? So just a quick preview. So question, what is log base 2 of 8? How can we even know that? Well, we're going to use this exponential form to understand it. Okay, so if I'm going to say log base 2 of 8 is equal to something, how can I understand what y actually is? Well, I'm going to convert it to its exponential form. I'm going to say, okay, what value y would make this true? Well, it's going to be the same value of y that makes this true. 2 to the power y is equal to 8. So 2 to the power y is equal to 8. In other words, what power do I raise 2 to that gives me 8? Right? We have to depend on our knowledge of exponential functions to answer this question. 2 to what power gives me 8? With a little bit of thought, you'll figure out that y should be 3. Right? 2 times 2 times 2, that gives you 8. And it turns out if there's one solution, that's the only solution. Okay, for exponential functions like this. So y is equal to 3 because 2 to the third is equal to 8. So log base 2 of 8 is equal to 3. That is how we're going to approach evaluating these functions. So I'll see you in the next video. We'll talk about more about evaluating logarithmic functions and their graphs.